Hey guys, what's up? Today we're going to be doing skill practice 45. And we're going to be learning about equilibriums. I'm Mark and I will be joining you today.
Oh, okay. All right, back. Skill practice 45. Oh, master. Okay, no. Let me just connect my iPad up. That was good. That was a good intro.
Yeah,
That was a good intro.
Fire intro.
As you know, like I do speak a little bit slow, so please feel free to speed up the video to your liking. Yeah, let's get. Oh my goodness.
7.1, but it's only one problem, so I can send you
So connect. Wait, I'll be right back. I bet I'm back. So I'm gonna talk with this microphone because there's background noise. So you're gonna have to get used to this camera angle. It's very flattering camera angle. Okay, so let's get right into it. What is meant when we say that a reaction has reached equilibrium? Equilibrium. So equilibrium, it's when the rates of the forward and reverse reactions are equal. Whoa, that was crazy. Okay. So like for rates, guys, just it has to be rates. It can't be concentration. It can't be anything else. It has to be rates. Okay, you feel me? So rate of forward and reverse. Uh, are equal. Okay. On to the next one. Consider the following chemical equation. N2O5, 2NO2O5. 2N2 and 5O2 at equilibrium. The concentration of O2 is at 0.45 and the concentration of N2O5 is 1.2. The concentration of N2 is 0.71. Find the constant equilibrium. That's K. So this is a simple product over reactant type of thing. You feel me? So this will be a product over reactant. So the product is N2. And then O2 is going to be super O2, right? All over that reactant, which is N2O5. However, guys, we're not done there yet. You feel me? You have to put the coefficients as the squared, right? So N2 is a thing of 2. So put the squared. O2 as a thing of 5. So put 5. And N2O5 is right here. So it's 2. All right, so you multiply all this out, right? For N2, it's 0.71.
13.2A last
0.71. For the squared of 0.45, right? For O2 to the 5th power, and it's all over 1.2 squared. And this, my friends, my good old friends, ladies and gentlemen, is going to give you a KEQ of 0.0065 molarity. Okay, I pray to God that the audio will turn out okay. All right. Wait. Okay. Yeah, on to the next one. Number 3. Sorry, I'm getting a little too distracted here. An experiment, 0.1 moles of H2 and 0.1 moles of I2 are mixed in a 3-liter container according to the following equation, right? That one. If K is 45, 50 for is 50 for this reaction, what is the equilibrium concentration? Oh my. Why?
What am I doing?
Just download it on your phone.
That's bad.
Okay, yeah, number 3. All right, so for number 3, right? this is going to be if 0.1 moles of H2 and 0.1 of I2 are mixed in the 3-liter container. According to the following experiment, K equals 50. What is the equilibrium constant? So this is a classic ice table. You know, it's ice tables because they give you moles, right? Moles and molarity is moles over volume, right? So set literal ice for H2, I2, and HI, right? H2 has to be H2 has to be so it's 0.1, right? Moles over volume. The volume is 3 liters. This can give you 0.03. So 0.03. I is also going to be 0.03. HI is going to be 0 because C is going to be X. It's going to be X as well. And the for HI it's going to be 2X. And this is because it's the coefficient is 2. Right. The reason why I put 2 there is because there's a 2 right here. And then remember, since the reactant, you guys put negative X. So for the E, you just drop things down 0.03 minus X, 0.03 minus X, 2X. Right. So let's just set up the equation. All right, so it's gonna be products over reactants. So
you multiply them?
products is gonna be 2X. Right, because under HI, 2X. 2X squared. The reason why it's squared is because there's a coefficient 2. All over 0.03 minus X. This 0.03 minus X. So this all equal to 50. Because the K is 50. So correct is it's right reactants. There's 2 reactants and they're both the same. 0.03, 0.03. Right. So 2X squared is also 2X. Both quantity squared is 4X squared all over. This is going to be 0.03 minus X squared, right? Because there's 2 of them, the 50. And you might be thinking to use Gracie's like cool trick, but this one just won't work for this equation. I asked Mr. Lee, and honestly, he said that something about like the H is too high or something about that. But don't worry, because you don't have to use quadratic formula in this one. Since both sides are squared, since the numerator and denominator are both squared, right?
So like because
Um, right. So since they're both squared, you can square root it, and you can square root both sides. You can't do this, right? If it's like 4X squared and like 0.03 minus X, because there's only a square on the numerator. However, since there's a square on both the numerator and denominator, you can just square both sides. So this will just give you the squares will cancel, the square root will cancel out. So this will give you 4X over 0.03 minus X equals 7.07, right? Let me move this up here. Paste. Okay. And then so you multiply both sides by 0.03 minus X. And for this reason, is because you want to get rid of the fraction bar. So this will give you yeah, this will give you 4X. Oh no. Sorry. There's something wrong here. This 2X squared. Oops. This 2X squared right here. I forgot to yeah, when you I shouldn't have squared both of it. It should just be 2X squared. All right, and the squares cancel out. So this will just be 2X. So this will be 2X, right? So when you come back to here, right? These cancel out, right? So this will be 2X equals equals 0.235 minus 7.07 x. You add both sides of 7.07. To get x on both on one side, and you'll get 9.07. X equals 0.235.
Okay, try parentheses like.
And divide both sides by 9.07. 9.07. Right, x is going to give you 0.0026. Right, you plug this back into x. This is your x. You plug this back into your x tables right here. Right, so H2 is going to be 0.03 minus the x is 0.0026.
I get 301.
I got 302.
Your x is going to be
Well,
0.03
4.16,
minus
so I'm going
0.026.
that's all you do?
You're gonna get
Just like testing on it.
and for H2 you're gonna get
Wasn't your fault.
0.004, I think. Well, let me check. Wait, haha, made a little mistake again. This should 7.07 times, oh shoot, 7.07 times 3.03 will give you point 2121, right? So this will be 0.2121. And then
It tells me the answer, but
so
you have to if I'm finding
so 0.2121 divided by 9.07 will give you
So maybe it's
0.023, right? And then right here, this will be 0.023. So 0.03 minus 0.0023 will give you 0.
so it matters about the
07,
I know.
right? That'll be for H. That'll be the same thing for I.
So if the rate also doubles, then it would be. Yes.
if the rate also then it would be
HI will be x 2x, so 2 times x, so 0.007, or no 0.0023 times
like
2 equals 0.0046. All right, what's the next one? All right, number 4.
If it stayed the same.
This is what.
All right, let's go. Okay, but let's get on with it. Number 4. How many moles of your substance is in a 1.0 liter vessel if you start out with 0.05 moles of H2? Right. Okay. So ice tables again. Right. Molarity is always moles over volume. So you have 0.05 moles over a 1 liter vessel, which is going to be 0.5 molarity. Right. So ice tables, ice here.
The video lesson. Where is it in class? Ah.
That was skill practice 43. I haven't.
oh you actually did
Yeah. So you have H2, so this would be this reaction problem can be the same thing as number 3. So it's gonna be H2 plus I2 equals 2HI. Right. H2 I2. Right. H2 will gonna be 0.5 molarity, right? We just said that earlier. 0.5. 2HI is gonna be 0. Your C constant is gonna be minus x, right? And then for the 2HI, since it's a coefficient of 2, it's gonna be plus 2x. So for E, it's gonna be 0.5 minus x, 0.5 minus x. Right, and then you just add them up, and then you just do products of reactants, right? So you're ready to set the equation. So 2x squared all over, right? Because it's squared because it's a coefficient of 2, all over 0.5 minus x squared.
There you go. So 100 minus
Right, equals 49.5, 49.7. 8 minutes. Okay, I can finish this. All right, so same thing as the last one. You can just square root both sides, and this will give you 2x. Right, the square roots cancel out. 2x equals 0.5 minus x equals square root of 49.7. Gonna give you 7.04, 7.05, I think, or 4. I'll just do 4. Right, you multiply both sides by 0.05 minus x. 0.05 minus x. Right, 2 times 0.05 will give you 2. All right, no, yeah, these cancel out, and then 7.05. Right, look in here, times 7.04. This will give you 2x, right, equals 0.352 minus 7.04x. Right.
And make sure your temperature is negative. Make sure that. Yeah, it changes on.
This is right here. Okay. And so you add oops. Go for it. It's the copy correctly. Okay, what did I do here? Oh yeah.
Oh, that's good.
Okay, it's right here. All right. So
How did we get?
you add both sides by 7.04.
Oh,
7.04. You get 9.04. 9.04x, right, will give you equals 0.35. Why is it? Is this one? What did I do here wrong? Oh yeah, sorry. Yes, it's gonna be 3.52. I did the calculation wrong. 3.52. Right. 3.52. Right. Oh my goodness, my voice is so cringy, dude. Okay, so 3.52 x divided both sides by 9.04, right? 9.04 divided by 9.04, 0.0389, right? So you just plug this back into x. 0.5 minus 0.0389.
No, sure. I meant sure.
Wait, why is it? Oh, sorry. It should be 3 point. It should just be 0.389. I did that calculation error wrong as well. Again, my bad. Yeah, so it's gonna be right, so 0.5 minus 0.389. To give you 0.11. So since H2 and I2 are gonna be the same, right? H2 are gonna be the same. It's gonna be 0.11. 0.11 molarity. And then for HI, you just get the x and multiply by 2, right? So the x is 0.389 times 2, to give you 0.778. Cool. On to the last one. Let's get it. Let's get it. Let us get it. So number 5, consider the following equation. Reaction with the initial concentration of PCl5 is 1 mole per liter. That's the equilibrium composition of the gaseous mixture, right? So this is going to be another ice table type of thing. This 1 mole over liter, that's also molarity, because moles over liters is also molarity. So ice Dude, that whiteboard's so annoying because it always gets that clicking sound. So PCL5, right? All right, so it's gonna be the molarity is 1. All right, PCl3 is gonna be Cl2, right? Cl2, the reactions and products. All right, so it's gonna be 1, 0, 0. C is gonna be minus X. PCl3 is gonna be plus X. Plus X, right? So X is gonna be 1 minus X. This is gonna be X, X. It's gonna be products over reactants, so X times X over 0.1 minus X equals 0.0211, right? This is also known as X squared over 1 minus X equals 0.0211, right? You multiply both sides by 1 minus X. 1 minus X. Oh, this is another one of those problems that you can actually get rid of the X, right? Why is everyone packing up already? Already at the door. So this is one of those equations where you can just actually get rid of the X. So it'll be X squared over 1. So X squared, you just square both sides, right? X will equal 0.0211 square that will be 0.145, right? So and then you just plug that back into X. So 1 minus 0.145, PCl5 will be 0.85, PCl3 will equal all right, same thing as X, so 1.45. And then the next Cl2 will be 1.45. All right, that's it. Sorry for all the miscalculation errors. I'm too tired to report it. Sorry about that. I'm not paid. Okay. This is so bad. All right, bye-bye.